What's good, Logan? All right, so this tutorial is on today's topic, which was on lines and circles and how they interact with each other. So the first thing is just making sure we understand what a circle is, and fairly simple idea. So let's go and draw a circle first. Let me get the right angle here. So we got to go 90 degrees. All right, so I'm gonna go ahead and draw my circle, right? So there's a circle. We got a center over there. And then the second part is that you're gonna have a line, right? So we can draw lines lots of different ways. We can draw a line so that it does no intersecting, right? So that right there is not lines intersecting circles. We could also draw the line so that it actually does intersect. So this right here is an example of a line that intersects a circle twice. You'll notice that this line right here intersects a circle at that point of intersection and at that point of intersection. Anytime a line intersects a circle twice, we call those lines secants. So this right here is a secant, right? So secant. So this is a secant right here. Now a secant is made up of, I would say, either two or three parts. I'm going to go with the word with two on this one here. The two parts that it's made up of is number one, the part that's on the outside. So it's that part of the secant and this part. And this is why some people might say three, because they'd say the first part outside and then the second part. I'm just going to say the parts on the outside. So the yellow parts outside the secant, and then we have outside the circle, and then we have the parts of the secant that are inside the circle. Now, this is important. This one right here, this green one, because we call those chords. So the secant is the entire line that goes through the circle, and then the part that's inside the circle is what we call a chord. So that right there is a chord. Now, if I was to erase this right here, okay, so if I erase this part right here and I erase this part right here, it would still be considered a chord, even though you don't see the rest of the secant. So remember, chords are just the parts, it's a segment, right? So that's a segment right there, that intersects a circle in two separate locations. That's one way that a line can interact with a circle. The first way is that the line doesn't cross the circle. That was the very first one we talked about. And then the second one is when a line intersects the circle in exactly one location. This one here is kind of weird, so this is what it would look like. It's when a line intersects a circle exactly at one place. You'll notice that this one right here, this line, there's only one part to it, and it's all outside the circle. So this is a line that is completely outside the circle, and it has a single point that intersects the circle, and that's that point right here. That's what we call the point of tangency. So this green line right here is what we call a tangent. We can write it over here. Is what we call a tangent line. And we would say that this line is tangent to the blue circle. Now, if this blue circle had a name, like let's say B, we would say that the green line, we can call that line L, the green line L is tangent to circle B, and the point that it is tangent at, that red dot right there, we could call that point C, is tangent to the point of tangency, also known as point C. So the point where the circle is intersected by a tangent line is called the point of tangency. So C is what we call the point of tangency. And this is the definition of a tangent. So a tangent line is a line that intersects a circle exactly at one point. Now, some of your classmates have been saying weird things and like, hey, Rocco, check this out. I can draw a tangent, and then they draw a line that's like that. This is a little misleading. If you were to extend this line, now remember, lines go infinite. If you were to extend this line as infinite as you can, you'll notice that this line will cross the circle at a second point, making it not a tangent. But when you take a look at the green line, regardless of how long I draw its infiniteness, right, and no matter how long I draw it, it will still intersect the circle at just one point. And that's why the green line we call a tangent, because no matter how long we draw it, it will only intersect the circle at just one point. Now, the whole premise of today was to make sure that you understood what tangent was, but it was also to introduce our very first theorem when it comes to lines that intersect circles, specifically the tangent. And this theorem states that if a line, the green line, is tangent to a circle, the blue circle, then you can conclude that the green line is perpendicular to the center. That means if you were to draw a radius, let's draw that a little bit more accurately. If you were to draw a radius from the center to the point of tangency, that red line must be perpendicular to the green line. In other words, the red line and the green line together form a right or a 90-degree angle. And this is really what we wanted you guys to walk away with. Now, on the homework tonight, there are a couple of complicated questions because of the algebra that's involved. So I kind of wanted to talk about that. So I'm going to grab this picture over here. We're going to move it over to the side. Remember, we're talking about tangents. And you're going to see a problem that kind of looks like this. So suppose you have something that looks like this, and then you have another line. So let's draw a couple of other, or one more line, not a couple, one more line. So I'm going to go from the center of the circle to that point right there. And we get a second secant, right? Or first secant. So we have a secant, and then, so the white line is a secant, the green line is tangent, and then the red line is our radius. And one of the things that they did on a problem like this is they're going to say something like, well, we don't know what the radius is. Sorry about that. Let's try that one more time. We don't know what the radius is. So from point B to here, we don't know what that value is. But what we do know is that the radius, no matter how you draw it, they must be the same. So those two things are the radius. We're going to solve for what that is. The second thing we know is that the tangent line from point C to this point right over here, we can call that point A, not L because L is the entire line. So line L is also now known as line AC. Let's say that that came out to 10, right? So if we know that CA, the tangent piece, right? So the segment of the tangent from C to A is 10, and this is where it gets a little trippy over here, is that if the point here, we can call this point D to A came out to, let's say, I don't know, let's say 6, right? So if point D was 6, well, sorry, not point D, if D to A was 6, and C to A was 10, is there a way we can figure out the radius of the circle? And you'll notice, and maybe you don't notice, the triangle, that's right, there's a triangle. The triangle that we have is a right triangle. And one of the things you remember is that when you're dealing with right triangles, trigonometry is allowed, but also Pythagorean theorem. And that's what I intend to use on this problem here, specifically because we're not talking about angles, we're trying to find angles. So Pythagorean theorem makes a lot more sense. Now the trick, and for your homework tonight, the trick is to figure out how long the hypotenuse is. I don't mean value wise, I mean expression. Is there an expression we can call that? Some people say that it's R, some people say that it's 6. Some people take R and 6 and just smush it together and say that it's R6 or 6R. I'm going to say that it's the segment, the radius, plus the 6. So it's R plus 6. So the hypotenuse is what we're going to call R plus 6. And then we have the shorter leg, the red one, which we're going to call R. And we have the longer leg, the green one, which we're going to call 10. And now we can use Pythagorean theorem. We would say that if we take the red leg, R squared, and we add it to the green leg, 10 squared, by adding those two things together, we should get the entire hypotenuse being squared. Now in this picture, the hypotenuse is R plus 6. So I'm going to write R plus 6, but it's the entire hypotenuse squared. So we have this equation, R squared plus 10 squared is equal to R plus 6 squared. Now we want to be really careful on the white part. I'm pretty sure the red and the green you guys are going to be okay with. R squared is just R squared. 10 squared is just 100. So we get R squared plus 100. But I think the part that a lot of people are going to get tripped up on is that algebra 1 part, the R plus 6 times R plus 6. So we're going to expand this. You cannot just go R times R and 6 times 6. You have to expand it out as a binomial, as a two-term grouping, a two-term addition. And then we're going to multiply this using the FOIL technique. So we're going to grab the r times r, which gives us r to the power of 2. Remember, r times r is r squared. And then we're going to have r times 6. So now we're going to do the outside terms, the r and the 6. That's going to give us 6r. Now, if you remember, when you FOIL or when you distribute, you have to multiply everything. So now we're going to multiply the inside terms. So we're going to go 6 times r, which gives us 6r. And then our last set of terms, which is 6 times 6, has 36. So plus 36 right in there. And now we have a quadratic equation that we can solve. Don't get too freaked out. It's not going to be super complicated, but there are r squares, so we're going to have to deal with that. So we have r squared plus 100, and all I'm going to do now is just kind of tidy it up. We're going to collect like terms. So we have r squared, 6r and 6r, we can add them. Now remember, it's not 6r squared, it's going to be 12r because we're adding, we're not multiplying right now. So we get 12r, 6 r's plus 6 more r's is 12 total r's, plus 36. Now, one of the things that I was talking about earlier this year, maybe about a month ago, is when I see r squared on both sides of an equation, it's kind of a nice thing because you can just subtract it from both sides and they cancel each other out essentially. So we're going to take away the r squared from both sides of the problem. What this results in is 100 is equal to 12r plus 36. And now we just solve this like any other equation. We're going to subtract the 36 from both sides of the problem. This gives us 64 is equal to 12r. And then we're going to divide both sides by 12. This is going to give us 64 over 12 is equal to r. Now, if we can reduce the fraction, we're going to go ahead and reduce that right now. 64 is 8 times 8, or if you were kind of, looking at it, some of you might say 4 times 16. I doubt most of you would say 4 times 16, but that's what I'm going to say. I'm going to say 4 times 16 is 64. And the reason I say that is because 12 is 4 times. Notice that we have a common factor, 4 times 3, and the 4's will cancel out. So our answer for this problem here is that r is equal to 16 thirds, or 16 over 3. And this is exactly how I anticipate you guys will approach these types of questions, using the fact that if a tangent, a line that intersects a circle at just one point, occurs, you can draw a radius, or you can draw the center to that point of tangency, creating a right angle. And then oftentimes what will happen is you'll get a right triangle, and this is going to allow for Pythagorean theorem, or even some of the trigonometry, sine, cosine, and tangent that we've talked about in the last couple of chapters. All right, if you guys have any questions, please hit me up. Otherwise, have a good night and best of luck on your homework.